September 12, 1944. 31,000 feet above Saipan, Mariana Islands. Lieutenant Commander Saburo Matsuda pressed his face against the cold glass of his Nakajima C-6N Sayun reconnaissance aircraft, the camera in his trembling hands clicking methodically as he photographed the American construction below. Through breaks in the morning clouds, he could see what Imperial General Headquarters had feared most: massive runways being carved from the coral and jungle, each one stretching nearly 2 miles in length, wider than anything he had ever witnessed. Enormous bulldozers crawled across the landscape like mechanical insects, moving enough earth in a day to build a small mountain. But it was what sat beside these unfinished runways that made Matsuda's breath catch in his throat. Even from 6 miles above, the silvered giants were unmistakable. B-29 Superfortresses. He counted them carefully, his navigator Lieutenant Hideaki Ono recording the numbers with mechanical precision: 12, then 20, then 37. The Americans were positioning an armada. "Ono-san," Matsuda transmitted through the intercom, his voice steady despite the ice forming in his gut. "Confirm those measurements, the runways." "Confirmed, Taisa," Ono replied, using the formal address. "Each runway measures 3,000 meters, width 60 meters. They are building 6 of them, 3 on Saipan, 2 on Tinian, 1 on Guam based on yesterday's reconnaissance." Matsuda understood the mathematics immediately. Runways that large, that numerous, meant one thing: the Americans intended to launch hundreds of bombers simultaneously. The home islands, which had remained largely untouched since Doolittle's pinprick raid over 2 years earlier, were about to face systematic annihilation from an enemy that could now reach Tokyo as easily as he could reach Iwo Jima. What Lieutenant Commander Matsuda didn't know, what none of the Japanese commanders analyzing his photographs over the next 72 hours could have comprehended, was that they were witnessing the deployment of a weapon against which their entire air defense strategy was obsolete. The B-29 Superfortress didn't just outrange Japanese fighters. It flew so high that most Japanese aircraft couldn't breathe the thin air required to intercept them. Its 4 Wright R-3350 engines, each equipped with turbo-superchargers that maintained sea-level power output at altitudes where Japanese fighters gasped and stalled, transformed the bomber into an untouchable giant that operated in atmospheric realms Japanese military science had never seriously considered defending. Within 9 months, these silvered monsters would grow from a single wing of 119 aircraft to 5 wings totaling over 1,000 bombers. They would systematically reduce Japan's major cities to ash, flying missions so large and so high that Japanese fighter pilots would describe their interception attempts as trying to catch clouds with bare hands. The mathematics of industrial warfare were being written in those Marianas runways, and Lieutenant Commander Matsuda had just photographed the beginning of Japan's systematic destruction from an altitude his countrymen could barely imagine reaching. The camera clicked one final time as Matsuda banked his reconnaissance aircraft northward for the 3-hour return flight to Iwo Jima. Below him, CB construction crews were already pouring concrete for hardstands that would eventually accommodate 180 B-29s per airfield. Above him, the stratosphere waited, soon to be filled with 4-engine bombers flying higher and faster than any Japanese fighter could consistently reach. The home island's defense rested on assumptions about distance and altitude that were about to be shattered by American engineering. Japan had believed the Pacific Ocean would protect them. They were about to discover that American turbo-supercharger technology had made geography irrelevant and altitude sovereign. The Boeing B-29 Superfortress represented the most ambitious military aircraft program in history, born from specifications that seemed impossible when first written. In January 1940, when Army Air Corps planners drafted requirements for what they called a hemisphere defense weapon, they demanded capabilities that exceeded anything flying: a range of 5,033 miles, a bomb load of 2,000 pounds carried at over 400 miles per hour, and a service ceiling of 35,000 feet. These weren't incremental improvements over existing bombers. They were requirements for an entirely new category of aircraft. Alexander Kartveli, Republic Aviation's brilliant Georgian-born designer, later admitted that when he first reviewed the specifications, he assumed they were typing errors. They wanted an aircraft, he recalled in a 1947 interview, that could fly from Hawaii to Tokyo, drop bombs and return, with a pressurized cabin, while carrying 10 men and defensive armament. It was madness. Beautiful madness, but madness nonetheless. Boeing's design team, led by Chief Engineer Edmund T. Allen, approached the problem with characteristic American pragmatism. If existing technology couldn't meet the requirements, they would invent new technology. The result was an aircraft so advanced that it required solving engineering problems that wouldn't appear in commercial aviation for another decade. The B-29 would be the first production aircraft with a fully pressurized cabin, allowing the crew to operate at extreme altitudes without oxygen masks. It featured remote-controlled defensive turrets coordinated by analog computers, a central fire control system that made the bomber bristle with precisely aimed firepower. Most revolutionary of all, it incorporated 4 General Electric turbo-superchargers, one for each massive Wright Cyclone engine. The turbo-supercharger was the key to everything. Unlike conventional superchargers driven mechanically by the engine, which consumed power to deliver compressed air, the turbo-supercharger used exhaust gases spinning a turbine at over 20,000 revolutions per minute. This turbine drove a compressor that forced air into the engine at pressures equivalent to sea level, even at 30,000 feet, where the atmosphere was thin enough to see stars in daylight. The system was brutally complex, involving miles of high-pressure ducting, automatic wastegates, and temperature controls that prevented the superheated compressed air from pre-igniting the fuel mixture. German and Japanese engineers understood turbo-supercharger theory. Both nations had experimented with the technology, but neither had mastered the metallurgy and precision manufacturing required to make turbo-superchargers reliable enough for combat operations. American industry, drawing on decades of experience with automotive turbochargers and high-altitude research, had solved problems that still baffled Axis engineers. The General Electric turbo-superchargers in each B-29 engine weighed 350 pounds, operated at temperatures exceeding 1,500 degrees Fahrenheit, and maintained their performance through combat maneuvers that would have destroyed earlier designs. The first XB-29 prototype took flight on September 21, 1942, piloted by Edmund Allen himself. The test was both triumph and tragedy. The massive bomber, weighing 105,000 pounds fully loaded, twice the weight of a B-17 Flying Fortress, lifted into the Seattle sky with surprising grace. Allen reported that the aircraft handled like a large fighter, responsive despite its size. But the complex systems required extensive development. On February 18, 1943, the second prototype suffered catastrophic engine failure during a test flight. Allen fought to control the burning aircraft, attempting to reach an emergency landing field, but the B-29 crashed into a meatpacking plant, killing Allen and his crew along with 19 workers on the ground. The disaster nearly killed the program. But Army Air Force Chief General Henry Hap Arnold pushed production forward with unprecedented urgency. He understood that defeating Japan required a bomber capable of reaching the home islands from bases beyond Japanese control. The B-24 Liberator and B-17 Flying Fortress, excellent aircraft in European skies, lacked the range for Pacific operations. Only the B-29 could bridge the vast ocean distances that protected Japan's industrial heartland. What followed became known as the Battle of Kansas. Boeing's Wichita plant, along with facilities operated by Bell Aircraft in Georgia, Martin in Nebraska, and Boeing's own Renton, Washington factory, began producing B-29s before all design problems were solved. Workers assembled aircraft while engineers were still modifying systems. Mechanics discovered flaws and invented solutions on production lines. The R-3350 engines, pushing the limits of piston technology, overheated regularly. The turbo-superchargers, operating at extreme temperatures and pressures, required constant adjustment. Early B-29s averaged one significant mechanical problem every 4 flight hours. But American production philosophy emphasized building and fixing simultaneously rather than perfecting before manufacturing. By April 1944, B-29s were arriving in the China-Burma-India theater for Operation Matterhorn, the first strategic bombing campaign against Japan. These early missions, launched from bases in China after fuel and bombs were transported over the Himalayas from India, demonstrated both the B-29's potential and the logistical nightmares of operating the complex bomber from primitive facilities. Major Robert K. Morgan, the Memphis Bell pilot who transferred to B-29s, described his first encounter with the Superfortress. "I thought the B-17 was impressive. Then I saw the B-29 and understood we weren't flying the same kind of war anymore. This wasn't a bomber. This was a flying battle station with the range of an ocean liner. You climbed a ladder into the nose, walked through a pressurized tunnel over the bomb bays plural, it had 2, and reached a crew compartment in back. The wingspan was longer than the distance from home plate to first base. And those engines. My God, those engines. Each one produced 2,200 horsepower. That's more power than 4 B-17 engines combined. The turbo-supercharger system gave the B-29 capabilities that seemed impossible to Japanese observers. At 25,000 feet, where a Mitsubishi A6M Zero fighter's engine produced perhaps 60% of its rated power, struggling for air in the thin atmosphere, the B-29's Wright Cyclones maintained full power output. At 30,000 feet, where the best Japanese fighters could barely maintain controlled flight, the Superfortress cruised comfortably at 350 miles per hour, its pressurized cabin keeping the crew warm and supplied with oxygen. The bomber could climb to 31,850 feet operationally, and had reached 35,000 feet in tests, altitudes where Japanese interceptors simply could not function. Japanese intelligence first detected the B-29's existence in late 1943 through reports from spies in neutral countries and from German intelligence sources. The specifications seemed like propaganda. A bomber larger than anything flying, faster than most fighters at altitude, with a combat radius exceeding 1,500 miles. When reconnaissance photos from China confirmed the reports in spring 1944, Imperial General Headquarters convened emergency meetings to assess Japan's air defense capability. The assessment was sobering. Japan's most capable high-altitude fighter, the Nakajima Ki-44 Shoki, could reach 10,000 meters, 32,808 feet, in just over 15 minutes. But at that altitude, the aircraft was operating at its absolute ceiling, barely controllable, with minimal maneuverability. The climb consumed so much fuel that combat time at altitude measured in minutes, not the hours needed to intercept bomber formations. Worse, Japanese 20mm cannons, effective against American fighters at medium altitudes, lacked sufficient range and hitting power against the ruggedly built B-29s. Pilots would need to close to within 300 meters, point-blank range where the bomber's defensive guns were devastatingly effective, to guarantee kills. The Technical Research Headquarters of the Imperial Army initiated crash programs to develop high-altitude interceptors. The Nakajima Kai-87 project, begun in July 1943, aimed to create a fighter specifically designed to combat B-29s at extreme altitudes. The aircraft would feature Japan's first operational turbo-supercharger system, developed through careful study of German research and Japanese experimentation dating to 1942. But turbo-supercharger technology that American engineers had refined over decades could not be replicated in months. The Ki-87 prototype didn't fly until April 1945, completing only 5 test flights before the war ended. By then, over 3,000 B-29s had been built, and Japanese cities were burning. The first B-29 raid on the Japanese homeland launched from China on June 15, 1944, targeting the Yawata Steel Works on Kyushu. 68 superfortresses took off from bases around Chengdu, though mechanical problems reduced the attacking force. Japanese air defenses, expecting an attack after reconnaissance detected the B-29 staging through China, had fighters positioned at altitude when the bombers arrived. Even so, interception proved nearly impossible. Lieutenant Yasuhiko Kuroe of the 4th Sentai, flying a Ki-45 Toryu twin-engine fighter, was among the few Japanese pilots to successfully engage B-29s during that first raid. His post-war account, recorded in 1952, captured the shock of encountering the American bombers. "We received warning they were coming. We climbed to 9,000 meters, full throttle, maximum power. My fighter was shaking, the engine temperature in the red zone. At that altitude, we barely maintained flight. Then we saw them, massive silver aircraft, flying in formation, as if they were at low altitude, completely unconcerned. They were above us. They were supposed to be bombers, heavy and slow, yet they were above us and moving faster than we could climb. I pushed my fighter higher, the controls barely responding. At 9,500 meters, the engine began cutting out. No more altitude. The Americans continued climbing, their formation disappearing into the stratosphere where we could not follow. We fired from below, long range, hopeless shots. I saw one B-29 trail smoke from an engine. It did not slow down. It did not leave formation. It continued as if nothing had happened. In that moment, I understood the war was lost. They owned the sky above us, and we could not reach them. The journey from concept to operational weapon system revealed the vast industrial and technological chasm separating American and Japanese military aviation by 1944. While Boeing engineers struggled with turbo-supercharger reliability and engine cooling problems, they worked within an industrial ecosystem that could solve problems through brute force testing and unlimited resources. Japanese engineers faced the same theoretical challenges, but lacked the metallurgical sophistication, precision manufacturing capability, and raw materials to implement solutions. The Wright R3350 duplex Cyclone engine represented American aviation power at its zenith. 18 cylinders arranged in 2 rows, each cylinder displacing 196 cubic inches, produced 2,200 horsepower at takeoff and maintained that power output to altitudes exceeding 25,000 feet through turbo-supercharger magic. The engine alone weighed 2,025 pounds, more than an entire Japanese Zero fighter engine and mounting structure combined. 4 of these monsters, synchronized by a maze of electrical systems and mechanical linkages, delivered 8,800 horsepower to the B-29's propellers, enough power to lift 135,000 pounds into the stratosphere. But such power came with brutal engineering challenges. The R-3350 generated heat that threatened to melt itself. Cylinder head temperatures exceeded 500 degrees Fahrenheit under full power. The magnesium alloy engine cases, chosen for their light weight, became heat-soaked ovens that required constant cooling airflow. Early production engines caught fire with alarming frequency. Mechanics working the Battle of Kansas production push in spring 1944 developed a grim joke. The B-29 doesn't fly on fuel. It flies on prayers and fire extinguishers. Wright Aeronautical Corporation's engineers attacked the cooling problem with typical American excess. They redesigned cylinder baffling 3 times, modified the cowl flaps twice, changed the ignition timing, altered the fuel mixture controls, and increased the cooling fin area by 40%. Each modification required changing production tooling, retraining mechanics, and retrofitting aircraft already built. The cost was staggering. Over $3 billion for the entire B-29 program, equivalent to the Manhattan Project's budget. But by late 1944, the engine fires had been largely tamed, and the R-3350 became reliable enough for 16-hour missions over hostile territory. Japanese observers who examined captured B-29 engines after the war expressed astonishment at the manufacturing precision. Captain Minoru Genda, one of Japan's finest pilots and a key planner of the Pearl Harbor attack, studied a Wright Cyclone engine at the Mitsubishi Research Facility in 1946. His report noted that cylinder machining tolerances measured in thousandths of an inch, valve timing mechanisms operated with Swiss watch precision, and the metallurgy of high-stress components exceeded anything Japanese industry could produce in quantity. Each engine, Genda wrote, represents manufacturing capability we could not match with our entire aircraft industry. The Americans built 3,970 B-29s during the war. Each aircraft carried 4 engines. 15,880 engines, each one a masterpiece of precision manufacturing. We could not have built 1,500 engines of this quality in 5 years, yet they built 16,000 in 2. The turbo-supercharger system added another layer of complexity that separated American capability from Japanese aspiration. General Electric's Type B-11 turbo-supercharger, mounted in the rear of each engine nacelle, consisted of a turbine wheel spinning at over 21,000 revolutions per minute, driven by exhaust gases at temperatures exceeding 1,500 degrees Fahrenheit. This turbine powered a centrifugal compressor that forced air into the engine at pressures up to 15 pounds per square inch above ambient atmospheric pressure. The compressed air, superheated by compression, passed through intercoolers before entering the engine's carburetor, preventing pre-ignition and detonation. The entire system operated automatically through a complex regulator that sensed manifold pressure, throttle position, and altitude, adjusting the turbo-supercharger's wastegate to maintain optimal boost pressure. Pilots monitored the system through an array of gauges showing turbine speed, manifold pressure, carburetor air temperature, and cylinder head temperature. When functioning properly, the turbo-supercharger was invisible to the crew. The engines simply maintained full power regardless of altitude. When malfunctioning, it could cause catastrophic engine failure within seconds. Master Sergeant Harold Weinstein, a B-29 flight engineer with the 73rd Bombardment Wing, maintained detailed logs of turbo-supercharger performance during missions from Saipan in 1945. His notes, preserved in the Air Force Historical Research Agency archives, reveal both the system's sophistication and its demands. Pre-flight check requires monitoring turbine speed at various power settings. On takeoff, turbos spool up to 17,000 RPM. Any fluctuation indicates wastegate problems. Abort immediately. At 20,000 feet, turbos maintain 52 inches manifold pressure. Watch exhaust gas temperature. Over 760 degrees Celsius means turbine failure imminent. At 30,000 feet, turbos running 21,000 RPM, air temperature through intercoolers critical. System works perfectly or fails catastrophically. No middle ground. Japanese attempts to develop equivalent technology foundered on multiple technical barriers. The Nakajima Army Air Arsenal's turbo-supercharger program, initiated in 1942 under direct orders from Imperial General Headquarters, secured German technical data on turbo-supercharger design through diplomatic channels. German engineers had experimented with exhaust-driven superchargers since the 1920s, achieving some success with high-altitude experimental aircraft. But German production turbo-superchargers proved unreliable, and the Luftwaffe had abandoned the technology in favor of mechanically driven superchargers for operational aircraft. The fundamental problem was metallurgy. Turbine wheels operating at extreme temperatures and rotational speeds required exotic alloys capable of maintaining strength at red heat while resisting oxidation and thermal fatigue. American manufacturers used nickel-chromium alloys developed through decades of research in automotive turbochargers and industrial turbines. These alloys, combined with precision casting and machining techniques, produced turbine wheels that could operate reliably for hundreds of hours. Japanese metallurgists lacked access to sufficient nickel and chromium. Domestic production of these strategic materials was limited, and shipping from occupied territories faced increasing submarine interdiction. Engineers attempted to substitute cobalt-based alloys and high-temperature steels, but these materials either lacked sufficient strength at operating temperatures or were too brittle for the extreme stresses. Test turbines frequently disintegrated during trials, sending shrapnel through engine nacelles with lethal force. Even when acceptable materials were obtained, Japanese precision manufacturing capability could not match American tolerances. Turbine wheel blades, each one a miniature airfoil, required machining accuracy within 0.001 inches across surfaces measuring less than an inch in length. American manufacturers used specialized grinding machines and inspection equipment that Japanese industry simply didn't possess in quantity. Hand finishing by skilled craftsmen could achieve similar results, but each turbine wheel required over 100 hours of labor versus 20 hours in American factories. The Ki-87 prototype that finally flew in April 1945 incorporated a turbo-supercharger system that was, by Japanese standards, an engineering triumph. The aircraft could reach 12,000 meters, 39,370 feet, and maintain combat capability at altitudes where conventional Japanese fighters were helpless. But 5 test flights completed before the war's end revealed chronic reliability problems. The turbo-supercharger overheated during extended operation. The wastegate control system responded sluggishly to throttle changes, and turbine wheel failures occurred during 2 of the 5 flights. Most damning, the aircraft required over 2 years of development and consumed resources desperately needed for conventional fighter production. Meanwhile, B-29s were arriving in the Marianas by the hundreds. The logistics of deploying the massive bombers to islands barely secured from Japanese defenders demonstrated American organizational capability as clearly as the aircraft demonstrated technological superiority. Navy construction battalions, the Seabees, transformed coral atolls into modern air bases at speeds that seemed impossible to Japanese planners. On Saipan, Tinian, and Guam, Seabee battalions built 6 major airfields between July 1944 and February 1945. Each airfield featured runways 8,500 feet long and 200 feet wide, constructed of coral and concrete, capable of supporting 55,000-pound aircraft. Each base included hardstands for 180 B-29s, fuel storage for over 3 million gallons of aviation gasoline, bomb storage for 20,000 tons of ordnance, maintenance facilities, housing for 5,000 personnel, and complete infrastructure, including power generation, water treatment, and communications. The North Field on Tinian, completed in February 1945, became the busiest airport in the world during the final months of the war. 4 parallel runways launched B-29s at 30-second intervals during maximum effort missions. Ground crews serviced aircraft around the clock, with complete engine changes accomplished in under 8 hours. Bomb loading crews could arm a B-29 with 20,000 pounds of ordnance in 45 minutes. The field operated with industrial efficiency that transformed strategic bombing from sporadic raids into systematic devastation. Japanese reconnaissance flights over the Marianas, conducted at extreme range and altitude by specially modified aircraft, photographed the buildup with increasing alarm. The images revealed not just airfields, but an entire military-industrial infrastructure transplanted across 6,000 miles of ocean. Fuel tank farms larger than Japanese naval bases, ammunition storage areas that dwarfed Japan's remaining strategic reserves, maintenance facilities equipped with machine tools and testing equipment superior to Japanese aircraft factories. Commander Mitsuo Fuchida, who had led the Pearl Harbor attack, reviewed reconnaissance photographs in September 1944 as part of an assessment for Combined Fleet Headquarters. His analysis, declassified in 1977, captured Japanese understanding of what the Marianas bases represented. The Americans have constructed a military city on coral reefs in 6 months. Their bases contain more aviation fuel than our entire home island's reserves. More bombs than we dropped in 2 years of war. More aircraft than we can field against them. This is not preparation for an air campaign. This is preparation for industrial-scale destruction. They intend to burn Japan city by city until surrender becomes our only option. The assessment proved prophetic. On November 24, 1944, Brigadier General Emmett Rosie O'Donnell led 111 B-29s from Saipan on the first Marianas-based strike against Tokyo. The mission, designated San Antonio 1, targeted the Musashino aircraft engine plant in the capital's western suburbs. Weather over Tokyo was terrible. Thick clouds obscured the target area, and 120-mile-per-hour jet stream winds scattered the formation. Only 24 bombers actually struck the primary target, and damage assessment photos showed minimal destruction. But the raid's strategic impact far exceeded its tactical results. For the first time since Doolittle's April 1942 pinprick raid, American bombers had struck the Japanese capital. More significantly, they had done so in broad daylight, at high altitude, against heavy defenses, and returned to their bases with acceptable losses. The psychological shock reverberated through Japanese society and military leadership. If the Americans could reach Tokyo at will, no city in Japan was safe. The Empire's defensive perimeter had collapsed inward to the home islands themselves, and even there, the stratosphere now belonged to the enemy. February 19th, 1945, 04:30 hours. Chofu Airfield, 20 miles west of Tokyo. Captain Teruhiko Kobayashi pulled on his leather flight jacket against the pre-dawn cold, his breath misting in the frigid air as he walked toward his Kawasaki Ki-61 Hien fighter. Around him, the 244th Sentai was preparing for another desperate dawn intercept. The alert had come 15 minutes earlier. Large formation of B-29s approaching from the south, estimated altitude 9,000 meters, estimated strength over 100 aircraft. Kobayashi, at 27, was already a veteran with over 300 combat sorties and 19 confirmed kills. His unit, the 244th, had become specialists in B-29 interception through brutal experience and mounting casualties. They had learned techniques that other Sentais hadn't survived long enough to master. But even Kobayashi understood that mastery of B-29 interception meant surviving long enough to make a single firing pass before the bomber's defensive guns or altitude advantage forced you to break away. His crew chief, Sergeant Takeshi Yamada, was doing final checks on the Ki-61's Kawasaki Hei-40 engine. The inline 12-cylinder engine, a licensed copy of the German Daimler-Benz DB601, was one of Japan's better high-altitude power plants. But better remained relative. The engine produced 1,175 horsepower at takeoff and maintained reasonable power to about 7,000 meters. Above that, performance degraded rapidly as the single-stage supercharger struggled against the thinning atmosphere. "Engine temperature is good, Taisa," Yamada reported, using the formal rank address. "All systems checked. Fuel load is maximum, 700 liters. Ammunition is full, 400 rounds for each cannon, 800 for machine guns." He hesitated, then added quietly, "The B-29s will be at 9,000 meters or higher. You'll have perhaps 3 minutes of combat time at that altitude before fuel becomes critical." Kobayashi nodded. He knew the mathematics of high-altitude interception intimately. The Ki-61 could reach 9,000 meters in approximately 16 minutes of climbing at full power, consuming nearly half its fuel in the process. At that altitude, the fighter's ceiling, the aircraft would be barely controllable, engine gasping for oxygen, controls mushy, maneuverability reduced to gentle turns that cost speed and altitude with every degree of bank. The B-29s, cruising comfortably in their pressurized cabins at 10,000 meters, would be flying faster than his struggling fighter could manage while also climbing. 3 minutes, Kobayashi repeated. "Then we make them count." The Ki-61s began their takeoff roll at 04:45 hours, 18 fighters lifting into the pre-dawn darkness. Kobayashi climbed at maximum continuous power, the engine temperature gauges creeping toward red zones as he pushed the aircraft upward. At 3,000 meters, he could see other Japanese fighters converging from airfields around Tokyo. Ki-44 Shokis from the 47th Sentai, twin-engine Ki-45 Torius from the 4th, even some obsolete Ki-43 Hayabusas, whose pilots knew they were climbing to their deaths, but climbed anyway. At 6,000 meters, 15 minutes into the climb, his radio crackled with a report from ground control. "Attention all aircraft. Enemy formation now at Choshi. Altitude estimated 10,000 meters. Formation proceeding directly toward Tokyo. Estimated 120 aircraft. No escort fighters detected." Kobayashi's wingman, Lieutenant Hiroshi Nakano, transmitted on the flight frequency. "Taisa, they're already above us. We'll never reach their altitude before they're over the target. We'll intercept from below. Kobayashi replied, though he knew the desperation in such tactics. Attacking from below meant exposing his fighters to the B-29's ventral gun turrets, while lacking the speed advantage that diving attacks provided. But there was no alternative. The Americans had learned to approach at maximum altitude, then enter a shallow dive over the target that accelerated them to speeds exceeding 400 kilometers per hour. Japanese fighters climbing to intercept simply couldn't catch aircraft that were simultaneously higher, faster, and diving away. At 8,000 meters, Kobayashi's vision began to narrow, the edges darkening as oxygen deprivation affected his brain despite the oxygen mask. The aircraft was shaking, the engine's cylinder head temperature in the red zone, propeller cavitating in the thin air. He advanced the throttle past the maximum continuous power setting into the emergency power range that was supposed to be limited to 5 minutes duration. The engine responded with a surge that felt more like a mechanical scream, RPM climbing, manifold pressure maxing out as the supercharger delivered everything it could to cylinders gasping for air. 9,000 meters. The altimeter's needle seemed stuck, crawling upward with agonizing slowness. Kobayashi's Ki-61 was at its absolute ceiling, barely maintaining altitude, any turn or speed change threatening to stall the aircraft into an unrecoverable spin. Around him, other Japanese fighters had reached their limits. Some were already descending, pilots recognizing the futility of climbing further. Others continued upward through sheer determination, their aircraft wallowing in stalls, falling away in helpless tumbles. Then he saw them. Silver crosses against the dawn sky, huge beyond comprehension, flying in tight formation at 10,500 meters, 1,500 meters above him. The B-29s were backlit by the rising sun, their polished aluminum skins reflecting light like mirrors. They appeared to be moving slowly, almost majestically, but Kobayashi knew this was an altitude illusion. Those bombers were traveling at nearly 400 kilometers per hour, and they were already beginning their bombing run over western Tokyo. All aircraft, he transmitted, forcing his oxygen-starved brain to focus. Attack from 7 o'clock low, diving attack on trailing element. Make your pass and break away immediately. Do not attempt sustained combat. He rolled his Ki-61 into a shallow dive that was more of a controlled descent, picking up perhaps 50 kilometers per hour of airspeed. The formation's trailing B-29 grew larger in his gun sight, its tail turret already tracking toward him. Kobayashi armed his weapons. 2 20mm Ho-5 cannons in the nose, 2 12.7mm machine guns in the fuselage. The cannons carried only 120 rounds each, at a firing rate of 850 rounds per minute. That meant less than 9 seconds of sustained fire. He would get one pass, perhaps 5 seconds of firing time if he was lucky, and then the B-29's defensive guns would drive him away or kill him. The distance closed. 800 meters. 700. The B-29's tail turret erupted in flame, twin 50-caliber machine guns sending tracers arcing toward his fighter. Kobayashi jinked slightly, the sluggish controls barely responding. 600 meters. The bomber filled his windscreen now, impossibly large, its fuselage wider than his fighter's wingspan. He could see the tail gunner's position clearly, the twin guns swiveling to track him. 500 meters. Now, he whispered, and pressed the firing button. The Ki-61 shuddered as both cannons and both machine guns fired simultaneously. Tracers reached out, converging on the B-29's left wing route. He saw strikes, bright flashes where 20mm shells impacted aluminum skin. The machine guns stitched a line across the fuselage, 50-caliber rounds punching holes in the bomber's tail section. He held the trigger down, walking the fire across the wing, seeing more strikes, feeling the aircraft shake with recoil. Then his ammunition ran out. 9 seconds of firing time had consumed his entire cannon ammunition load. The machine guns continued for another 3 seconds before they too fell silent. Kobayashi broke left and down, diving away, glancing back at the B-29. It was still flying, still in formation. He could see damage, holes in the wing, damage to the tail section. But the bomber continued as if nothing had happened. Both engines on the damaged wing were running. The aircraft hadn't even left formation. "Taisa!" Nakano's voice screamed over the radio. "Brake right!" Kobayashi rolled instinctively, looking up to see another B-29 above him, its dorsal turret tracking his fighter. 4 50 caliber guns opened fire. The world exploded in tracers. Kobayashi felt impacts, thudding crashes as heavy machine gun rounds tore through his aircraft. The canopy exploded in a shower of plexiglass. The instrument panel disintegrated. Something hit his left arm with sledgehammer force, spinning him against the harness. The Ki-61 was dying. Engine temperature suddenly red-lined as coolant lines severed, oil pressure dropping to 0. Control cables shot through. The aircraft entered a spin, Kobayashi fighting controls that no longer responded. At 8,000 meters, he made the decision that would save his life and haunt his conscience. He reached for the canopy jettison handle with his uninjured right arm. The slipstream tore him from the cockpit. The parachute deployed automatically at 7,000 meters, the shock of opening nearly dislocating his injured left arm. Kobayashi hung in the silk, watching the battle continue above him. More Japanese fighters were attacking, their tracers reaching toward the B-29 formation. But the bombers continued their run, unperturbed, their formations intact. Below, Tokyo was beginning to burn as bombs fell, creating fires that would merge into a conflagration, visible for 100 kilometers. He counted the Japanese fighters attacking. Then he counted the ones withdrawing, damaged, trailing smoke, or simply breaking away with ammunition exhausted. The mathematics were brutal. Perhaps 30 fighters had engaged the formation. He could see 6 parachutes beside his own. That meant 7 pilots surviving, the rest dead, crashed, or wounded badly enough to be unable to bail out. And the B-29s? He watched them carefully during his descent. 2 were trailing smoke. 1 had left formation, losing altitude gradually. Perhaps 3 bombers damaged badly enough to be counted as victories, though even the worst-hit aircraft might survive to ditch near American submarines positioned along the flight path. 30 fighters engaged, 23 lost, 3 bombers damaged. The exchange rate made continued resistance suicidal. And this was just one raid on one morning. The Americans launched these attacks every few days, sometimes daily, with formations growing larger each time. Japan simply didn't have enough pilots or aircraft to maintain this kind of attrition rate. Kobayashi landed in a rice paddy 20 kilometers west of Tokyo, his injured arm hanging useless, his aircraft a smoking crater 2 kilometers away. Local farmers helped him to a military telephone, from where he called his base to report. The operations officer who took his report asked the question that Kobayashi couldn't answer. "Taisa, you damaged 1 bomber with cannon fire. How many cannons would be needed to shoot one down?" Kobayashi thought about the strikes he'd observed, the apparent imperviousness of the B-29 to his weapons. "I put perhaps 20 rounds into 1 aircraft at close range," he said slowly. It continued flying. The Americans build them like battleships. To guarantee a kill, I would estimate 60 to 80 20mm hits, or perhaps a dozen 30mm rounds, if we had 30mm cannons in quantity. And to destroy a formation of 120 bombers? The mathematics were simple and hopeless. 7,000 20mm rounds on target. That would require approximately 70 fighters making perfect attacks with perfect accuracy. We put 30 fighters into the battle this morning. We lost 23. This is not sustainable. The operations officer was silent for a moment. Then, report to the base hospital for treatment of your injury, Taisa. The Emperor thanks you for your sacrifice. But Kobayashi understood that thanks meant nothing against the strategic reality. The Americans could afford to lose bombers. They built them faster than Japan could shoot them down. Japan couldn't afford to lose pilots. The 244th Sentai had begun the war with 45 pilots. After this morning's battle, 18 remained fit for duty. Replacements arrived weekly, boys with 30 hours flight time, who died in their first or second mission. The Americans' crews had hundreds of hours training and flew bombers that could absorb damage no Japanese aircraft could survive. That evening, lying in the base hospital with his shattered arm set in a cast, Kobayashi wrote in the diary he'd kept since 1942. The entry, discovered after the war and translated for American intelligence, captured the despair spreading through Japan's fighter units. We are samurai attacking battleships with bamboo spears. The B-29s fly higher than we can effectively fight, faster than we can chase, and survive punishment that would destroy any aircraft we possess. Their turbo-superchargers give them the stratosphere. We climb to our ceilings and find them above us, untouchable. The technological gap is not years, it is generations. We cannot win by courage or sacrifice. We need miracles, and America manufactures miracles in quantities we cannot imagine. The 244th Sentai would continue flying interception missions until the war's end. Of the 45 pilots who began the war with the unit, only 7 survived to surrender. Kobayashi was one of them. Grounded after his arm injury healed improperly, leaving him unable to fly fighters, he spent the war's final months training replacement pilots, sending boys to die against an enemy that owned the sky above 9,000 meters. His unit's confirmed kill count, 17 B-29s destroyed. Cost, 38 pilots killed, 7 permanently injured. Exchange rate, 2.2 pilots per bomber. Unsustainable, unwinnable. The mathematics of a lost war written in burning cities and falling fighters. The pattern of futility that Captain Kobayashi experienced over Tokyo on February 19th repeated itself across Japan's skies with mounting intensity through the spring of 1945. But the evolution of American tactics transformed the B-29 campaign from high-altitude precision bombing into something far more devastating. Low-altitude incendiary attacks that exploited Japanese inability to counter night operations. Major General Curtis LeMay, who assumed command of WWII Bomber Command in January 1945, understood that high-altitude precision bombing, the doctrine that had guided European operations, wasn't working over Japan. The jet stream winds at 30,000 feet, sometimes exceeding 200 miles per hour, scattered bomber formations and made accurate bombing impossible. Cloud cover obscured targets for weeks at a time. Most significantly, the strategic targets that precision bombing aimed to destroy, aircraft factories, steel mills, oil refineries, were increasingly dispersed into small workshops scattered throughout residential areas. Destroying Japan's war production required destroying Japanese cities. LeMay's solution was radical and, by the standards of military convention, insane. On March 9, 1945, he ordered 334 B-29s to attack Tokyo at night, from altitudes between 5,000 and 8,000 feet, carrying nothing but incendiary bombs. To maximize bomb loads, he ordered most defensive armament removed. Only the tail guns would remain. The bombers would fly individually rather than in formation, approaching from different directions to overwhelm Japanese defenses. The plan horrified LeMay's air crews. Captain Robert Rodenhouse, piloting a B-29 from the 504th Bombardment Group, recalled the briefing. LeMay stood up and said we were going in at 5,000 feet. 5,000 feet. You could throw rocks at us from 5,000 feet. Every gun in Tokyo would have clear shots. We thought he'd lost his mind. Then he said we were stripping the guns to carry more incendiaries. We'd be flying naked bombers through the most heavily defended city on Earth. But LeMay had calculated that Japanese night fighter capability was minimal. Anti-aircraft guns lacked the fire control systems for effective low-altitude night interception, and searchlights could be overwhelmed by attacking from multiple directions simultaneously. More importantly, Japanese cities, constructed largely of wood and paper, would burn with apocalyptic intensity when hit with concentrated incendiaries. A successful fire raid would accomplish more than months of high-altitude precision bombing. The night of March 9 to 10, 1945, proved LeMay correct and rewrote the rules of strategic bombing. The first B-29s arrived over Tokyo at 12:15 a.m. Pathfinder aircraft dropping incendiary clusters that marked the target area with flames visible for 50 miles. Following bombers released their loads into the fires, creating a conflagration that generated its own weather system. Superheated air rising created winds exceeding 100 miles per hour at ground level, sucking oxygen from the atmosphere and turning 16 square miles of Tokyo into a firestorm. First Lieutenant James Patillo, bombardier on a B-29 making one of the later drops, watched the scene below with horror and awe. Tokyo was gone, replaced by a lake of fire. The heat was so intense we could feel it at 7,000 feet. The smell of burning flesh came through the pressurization system. We were bombing coordinates, not buildings. There were no buildings left, just fire. The navigator said the smoke column reached 30,000 feet. We could see it from 100 miles away. A pillar of smoke that looked like a volcano had erupted under the city. Japanese ground defenses, configured for high-altitude raids, proved helpless against the low-level night attack. Searchlights illuminated bombers effectively, but anti-aircraft guns lacked the depression to engage targets below 10,000 feet. Night fighters scrambled too late, and the few pilots who reached the bomber stream found themselves trying to intercept individual aircraft scattered across hundreds of square miles, flying at speeds that made visual interception in darkness nearly impossible. Lieutenant Commander Sadamu Komachi, flying a Nakajima J1N1S Gecko night fighter who was from Yokosuka, managed to close on one B-29 during the raid. His after-action report, preserved in Japanese naval archives, captured the tactical impossibility. Located enemy bomber by searchlight illumination. Attempted pursuit at 6,000 meters. Enemy aircraft dove to 2,000 meters, accelerating beyond our maximum speed. We followed into the smoke and lost visual contact. The entire sky was smoke and fire. Instruments useless in the turbulence. Infrared detector overwhelmed by heat from fires below. Attempted to locate targets by sound. Impossible over engine noise and roar of fires. Returned to base after 30 minutes. No confirmed intercepts. The human cost was staggering. American intelligence estimated 88,000 Japanese killed and 41,000 injured. Japanese authorities later revised the figure upward to over 100,000 dead and 125,000 wounded. 1 million people lost their homes. The Tokyo Fire Department, overwhelmed within the first hour, simply abandoned firefighting efforts and focused on evacuating survivors. The fires burned for 4 days, consuming everything combustible within the target area. For Japanese civil defense officials, March 10th represented the complete collapse of their air raid protection plans. Iwao Yamazaki, Japan's Minister of Home Affairs, concluded in his official report that civil defense against incendiary attacks was considered to be futile. Fire breaks that were supposed to stop conflagrations proved useless against winds that carried burning debris across multiple city blocks. Public shelters designed to protect against high explosive bombs became death traps as fires consumed oxygen and temperatures exceeded 1,800 degrees Fahrenheit. Evacuation plans failed when streets became rivers of flame. The success of the Tokyo firebombing triggered a systematic campaign against every major Japanese city. Over the next 10 days, B-29s launched massive incendiary raids against Nagoya, Osaka, and Kobe, destroying 32 square miles of urban area and killing tens of thousands. The tactics remained consistent. Night attacks, low altitude, maximum incendiary loads, individual aircraft routing to overwhelm defenses. Japanese fighter units, already depleted by months of futile high-altitude interception attempts, proved even less effective against low-altitude night raids. The 302nd Naval Air Group, equipped with J-1N-1 Gecko night fighters specifically designed for bomber interception, managed only sporadic successes. Between March 10th and the war's end, the unit claimed 12 B-29s destroyed at night, losses the Americans replaced in less than a week of production. The fundamental problem remained altitude and technology. Even when Japanese night fighters located B-29s, the bombers could outrun pursuit by diving and accelerating. Master Sergeant Takeo Tanamizu, a veteran radar operator with the 302nd, described the frustration. Our radar detected them clearly: individual aircraft, altitudes, bearings. We vectored fighters to intercept. But by the time our pilots reached the area, the B-29s had changed altitude and heading. They flew faster at low altitude than we expected. Their pilots used cloud cover brilliantly, and if intercepted, they simply dove and accelerated beyond our pursuit speed. We could track them but not catch them. The daytime high-altitude raids continued alongside the night incendiary campaign, and here Japanese fighters maintained somewhat better success rates. But better remained relative. Lieutenant Colonel Naoshi Kano, one of Japan's most skilled fighter leaders, developed tactics specifically for B-29 interception that required exceptional flying skill and iron discipline. Kano's method involved positioning fighters above the B-29 formation's cruising altitude before the bombers arrived, typically at 11,000 or 12,000 meters. This required climbing to absolute ceiling and loitering there, engines barely running, pilots breathing supplemental oxygen, aircraft on the edge of stalling. When B-29s appeared below, Kano's pilots would roll inverted and dive, building speed to 700 kilometers per hour, fast enough to close with the bombers before their defensive guns could track effectively. The diving attack would last perhaps 5 seconds, pilots firing their cannons and machine guns in one concentrated burst before pulling up violently, using their diving speed to climb back above the formation. Then they would repeat the process if fuel and ammunition remained. The tactic was effective. Kano's unit claimed 15 B-29s destroyed in April 1945, but brutally demanding. Pilots who misjudged the dive hit the ground. Those who pulled up too late entered the B-29 formation's defensive fire and died. Those who hesitated or delayed attacking ran out of fuel at altitude and crashed. Cano himself died on August 1, 1945, when his Ki-84 fighter disintegrated during a high-speed diving attack on a B-29 formation. The aircraft's wings failed from excessive G-forces as he pulled out of the dive, structural limits exceeded by the extreme maneuvers required to fight at the stratosphere's edge. He was 23 years old, one of Japan's finest fighter pilots, killed by the physical demands of fighting an enemy who owned the high-altitude battlefield. By May 1945, the strategic bombing campaign had achieved what precision attacks never could. It paralyzed Japanese industry not by destroying factories, but by rendering workers homeless, transportation networks destroyed, and electrical power systems crippled. Osaka, Japan's second-largest city, was 50% destroyed. Nagoya, center of aircraft production, was 40% gone. Kobe, a major port, was 55% burned. Tokyo, the capital, was 51% destroyed, with entire wards reduced to ash. The psychological impact on Japan's population was devastating. Yutaka Akabane, a senior civil servant who survived the firebombings, later testified about civilian morale. It was the raids on medium and smaller cities which had the worst effect, and really brought home to the people the experience of bombing and demoralization of faith in the outcome of the war. It was bad enough in so large a city as Tokyo, but much worse in the smaller cities, where most of the city would be wiped out. Through May and June, the spirit of the people was crushed. When B-29s dropped propaganda pamphlets, the morale of the people sank terrifically, reaching a low point in July, at which time there was no longer hope of victory or draw, but merely desire for ending the war. The Imperial Japanese Army Air Force and Navy Air Service, meanwhile, faced arithmetic impossibility. Between November 1944 and August 1945, American bombers flew approximately 33,000 combat sorties over Japan. Japanese fighters launched approximately 11,000 interception attempts. B-29 gunners claimed 714 Japanese aircraft destroyed, 456 probably destroyed, and 770 damaged, claims that were likely exaggerated but reflected intense air combat. Japanese records, fragmentary and incomplete, suggest actual losses were somewhat lower, but still catastrophic for a nation unable to replace pilots or aircraft. The Americans lost approximately 450 B-29s during the campaign, a 1.4% loss rate considered acceptable for strategic operations. Each lost bomber carried 11 crewmen, meaning roughly 5,000 American airmen were killed, captured, or missing. Japanese forces claimed significantly higher numbers, but post-war analysis confirmed the American figures were substantially accurate. The technological and industrial gap meant that losing 450 bombers was strategically irrelevant. Boeing, Martin, and Bell were producing that many B-29s every 3 weeks. In April 1945, Imperial General Headquarters made a desperate strategic decision: withdraw remaining fighters from air defense duties and preserve them for defending against the anticipated American invasion. The logic was brutal but unavoidable. Fighters expended uselessly against B-29s would be unavailable for kamikaze attacks against invasion fleets. Japan had lost the air defense battle. The only remaining question was whether enough aircraft could be preserved to make invasion prohibitively costly. Major Yoshitake Miwa, operations officer for the Air Defense Command, recorded the decision's implications. "We are abandoning our cities to fire. Millions of civilians will die." But we have no alternative. We cannot stop the B-29s. Every fighter sent against them is one fewer for the final battle. The Americans fly higher than we can effectively fight. Their production replaces losses faster than we inflict them. Their technology, the turbo-superchargers, the pressurized cabins, the fire control systems, gives them advantages we cannot counter. We are conserving our forces for the invasion, where altitude won't matter, and our pilots can die striking enemy ships rather than dying uselessly in the stratosphere. The withdrawal of fighters from air defense meant that subsequent B-29 raids encountered minimal opposition. On May 29, 1945, 517 B-29s attacked Yokohama in broad daylight, escorted by 101 P-51 Mustang fighters flying from Iwo Jima. Japanese forces managed to scramble only 150 fighters, mostly obsolete A-6M0s flown by undertrained pilots. 5 B-29s were shot down. The P-51s claimed 26 Japanese fighters destroyed. The 454 B-29s that reached the target destroyed 6.9 square miles of the city, killing over 1,000 and rendering the port facilities inoperable. The one-sided battle demonstrated that Japanese air defense had effectively ceased to exist. The skies belonged to America, and the turbo-supercharged B-29s that had seemed invincible at 30,000 feet now flew at medium altitudes in daylight, unopposed, systematically reducing Japan to rubble. The industrial mathematics behind the B-29 campaign told a story of American productive capacity that Japanese planners had never imagined possible. Between 1943 and 1945, 4 production facilities, Boeing in Wichita, Kansas, and Renton, Washington, Martin in Omaha, Nebraska, and Bell in Marietta, Georgia, built 3,970 B-29 Superfortresses. Each aircraft required approximately 55,000 individual parts fabricated to tolerances measured in thousandths of an inch. Each bomber consumed 1,000 pounds of aluminum, 600 pounds of steel, 150 pounds of copper, and 50 pounds of rubber. Each airframe demanded 160,000 man-hours of labor at peak efficiency, reduced from over 200,000 hours for early production aircraft through continuous process improvement. The Wichita plant alone, Boeing's largest wartime facility, reached production rates that stunned even American observers. By early 1945, the facility was completing 4.2 B-29s per working day, one every 5.7 hours around the clock, 7 days a week. The assembly line stretched across 2.3 million square feet of factory space, employing over 30,000 workers at peak capacity. Raw aluminum entered at one end. Finished bombers rolled out the other, each one flight-tested and delivered to the Army Air Force within 30 days of fuselage start. The workers themselves represented a revolution in American labor. Women comprised over 40% of the workforce at Boeing Wichita, performing jobs that had been exclusively male before the war. Rosie the Riveter wasn't propaganda. She was Mary Parker, age 23, who operated a rivet gun on B-29 engine mounts, placing 1,200 rivets per shift with error rates below 0.1%. She was Dorothy Wright, age 19, who welded aluminum alloy fuselage sections with torch precision that exceeded peacetime standards. They worked 10-hour shifts, 6 days a week, building bombers that would fly higher and farther than any aircraft in history. Japanese intelligence officers who examined captured production records after the war struggled to comprehend the scale. Commander Minoru Genda, analyzing Boeing Wichita output data in 1946, calculated that this single factory produced more heavy bombers in 2 years than the entire Japanese aircraft industry built of all types during the war. One American facility, employing workers who had been civilians 3 years earlier, outproduced an empire. The implications weren't just tactical or strategic, they were civilizational. The cost of the B-29 program, approximately $3 billion, equaled the Manhattan Project's budget and exceeded the total military expenditure of most nations during the war. Each B-29 cost roughly $639,000, equivalent to $10 million in 2024 dollars. The program consumed 20% of all aluminum production in the United States during 1944. Engine production alone required the output of 3 dedicated Wright aeronautical factories running continuously. The turbo-supercharger systems, manufactured by General Electric, demanded exotic materials and precision manufacturing that absorbed significant fractions of American nickel, chromium, and specialty steel production. Yet this massive expenditure represented only 4% of total American military spending during World War II. The United States could afford to develop, produce, and operate the most expensive weapon system in history, while simultaneously building aircraft carriers, submarines, tanks, artillery, and supplying allies through Lend-Lease. This economic capacity, more than any tactical innovation, determined the war's outcome. The human stories behind the production statistics revealed how industrial mobilization transformed American society. Robert Henderson, a farmer from Iowa who became a B-29 flight engineer, recalled his training in 1944. "I'd never seen anything more complex than a tractor engine. They handed me a technical manual for the R-3350 that weighed 15 pounds. 700 pages of systems, specifications, procedures. They gave us 8 weeks to learn every system on the aircraft. Most of us made it. We weren't smarter than Japanese mechanics. We just had better training systems, better equipment, and the assumption that ordinary people could master complex technology if properly taught. That assumption, that average citizens could be trained to build, maintain, and operate the most advanced weapons in the world, separated American military philosophy from Japanese hierarchical traditions. The Japanese system relied on elite specialists and master craftsmen. American industry assumed that any reasonably intelligent person could be trained to perform complex tasks if systems were properly designed and documented. This democratic approach to technology enabled the massive production increases that Japanese planners considered impossible. The B-29 crews themselves embodied this philosophy. They were not warrior elites or samurai. They were accountants, farmers, mechanics, teachers, civilians in uniform, trained through standardized programs, flying missions in aircraft maintained by other civilians in uniform. The average B-29 crew consisted of 11 men with a combined age of 242 years, average individual age of 22. They had minimal combat experience before their first missions, but operated complex aircraft through procedures refined to checklist precision. Lieutenant Commander Saburo Matsuda, the reconnaissance pilot who had photographed Saipan's airfields in September 1944, survived the war as an intelligence officer analyzing American bombing campaigns. In 1952, he wrote a memoir that captured Japanese understanding of what the B-29 represented. "We knew the Americans possessed industrial capacity. We had seen their automobiles, their factories, their movies depicting abundant consumer goods. But we believed this softness, this consumer orientation, made them weak militarily. We thought nations grew strong through austerity and sacrifice, that warriors defeated manufacturers. The B-29 proved we were catastrophically wrong. American abundance was their strength, not weakness. They built bombers with the same efficiency they built automobiles, standardized, mass-produced, maintained through systematic procedures rather than individual craftsmanship. Their pilots were trained through industrial education methods, not warrior traditions. Their mechanics were taught to replace components, not repair them. They had such abundance that replacement was cheaper than repair. Most devastating was the turbo-supercharger. This single technology gave them the stratosphere. We could build aircraft, inferior aircraft, but aircraft nonetheless. We could train pilots, poorly trained compared to theirs, but pilots who could fly and fight. We could manufacture weapons and ammunition, but we could not build reliable turbo-superchargers in quantity. This one technology, requiring precision manufacturing and exotic materials we lacked, gave them altitudes we could not reach and performance we could not match. I remember photographing those airfields in September 1944, seeing the first B-29s arriving. I knew then the war was lost, not because we lacked courage or determination, because they owned the stratosphere, and we could only reach it briefly at our aircraft's limits, while their bombers cruised there comfortably in pressurized cabins. The mathematics of altitude determined the mathematics of defeat. The strategic impact extended beyond immediate military effects. The B-29 campaign destroyed approximately 40% of Japan's urban areas, killed between 241,000 and 900,000 civilians depending on estimates, and displaced 5 million people from their homes. Industrial production collapsed, not primarily from factory destruction, but from infrastructure devastation. Workers couldn't reach factories through burned cities. Power systems couldn't deliver electricity through destroyed grids. Transportation networks couldn't move materials through ruined rail yards. By August 1945, Japanese war production had declined 50% from peak levels despite desperate efforts to maintain output. Aircraft production, dispersed into small workshops to avoid bombing, averaged 1,500 planes monthly. Aircraft that couldn't fly for lack of fuel, couldn't be maintained for lack of parts, and couldn't be piloted effectively for lack of trained crews. The B-29 campaign hadn't destroyed Japanese industry through precision targeting. It had paralyzed the economic system that sustained industry through systematic urban devastation. The final act of the B-29's war came on August 6th and 9th, 1945, when specially modified silver-plate B-29s dropped atomic bombs on Hiroshima and Nagasaki. The Enola Gay and Bockscar, stripped of defensive armament and modified to carry 10,000-pound weapons, flew missions that killed over 200,000 people and shocked Japan into surrender. But these atomic attacks, while historically momentous, were tactically similar to what B-29s had been doing for months, destroying cities from altitudes Japanese forces couldn't effectively defend. The turbo-supercharger technology that enabled these missions would transform post-war aviation. Commercial airliners adopted turbo-supercharging and then pure jet engines, allowing routine stratospheric flight. Modern aircraft operate at altitudes the B-29 pioneered, in atmospheric realms that seemed impossible in 1940. The pressurized cabin, once a revolutionary feature, became standard on every airliner. The system's integration and quality control procedures developed for B-29 production influenced manufacturing across industries. But for the Japanese commanders and pilots who fought against the Superfortress, its legacy was more personal and immediate. They had faced a weapon that rendered their tactical skill, courage, and sacrifice strategically irrelevant. No amount of warrior spirit could overcome the physics of altitude and the mathematics of industrial production. Captain Teruhiko Kobayashi, recovered from his injuries and survived to witness Japan's surrender, stood in the ruins of Tokyo in September 1945, watching American occupation forces arrive. Around him stretched 16 square miles of ash and rubble, the remnants of the city destroyed by weapons he couldn't reach, delivered by aircraft he couldn't catch, built by a nation whose productive capacity he couldn't comprehend. The same Lieutenant Commander Matsuda, who had photographed Saipan's airfields in September 1944, stood beside him, both men survivors of a lost war. They watched a B-29 fly overhead, cruising at perhaps 10,000 meters, its polished aluminum skin reflecting the autumn sun. No Japanese fighters rose to intercept. The air defense system had been dismantled, the fighters scrapped or captured, the pilots returned to civilian life or dead in battles they couldn't win. That morning over Saipan, Matsuda said quietly, when I photographed those runways and counted those silver bombers, I knew what was coming. I knew we couldn't stop them. But I didn't understand how completely technology could determine war's outcome. We thought spirit would overcome material, that courage would defeat machinery, that our warrior traditions would prove superior to their industrial systems. Kobayashi touched his left arm, still weak from injuries sustained in his last combat mission. I put 20 20mm rounds into one of them from 300 meters. Perfect shooting. It didn't even leave formation. I needed 80 rounds to guarantee a kill. We never had 80 rounds. We never had aircraft that could reach their altitude and fight effectively. We never had pilots in sufficient numbers with sufficient training. We had courage. They had turbo-superchargers. Technology won. The B-29 overhead continued north, disappearing into the distance, its engine's rumble fading gradually. That sound, the deep thunder of 4 R-3350 engines, each boosted by turbo-superchargers that maintained sea-level power at 30,000 feet, had been the soundtrack of Japan's defeat. Between November 1944 and August 1945, Japanese defenders had heard it over 300 times, as formations exceeding 100 bombers systematically reduced their nation to ruins. The final statistics told the story that courage couldn't overcome. 3,970 B-29s built, approximately 33,000 combat sorties flown, 147,000 tons of bombs dropped on Japan, 50% of urban areas in major cities destroyed. Against this industrial onslaught, Japanese forces had claimed approximately 450 B-29s destroyed, a 1.4% loss rate that America replaced through 3 weeks of production. The exchange rate was 8.8 bombers built for every one lost, mathematical proof that industrial capacity determined modern war's outcome more than tactical brilliance or warrior dedication. Japan never expected turbo-superchargers to give B-29s the stratosphere. They never imagined that American industry could build precision machinery in such quantities. They never comprehended that democratic societies could mobilize resources with efficiency matching or exceeding totalitarian systems. The distance that they thought protected them, 6,000 miles of ocean, became irrelevant when aircraft could fly higher than defenders could reach. The pencil that Lieutenant Commander Matsuda had used to record measurements over Saipan in September 1944 had trembled not from fear, but from recognition. He understood immediately that the massive runways and silver bombers meant systematic destruction from an altitude his countrymen couldn't defend. 15 months later, standing in Tokyo's ruins, the truth was inescapable. Technology had won the war, and the turbo-supercharger, that complex marriage of metallurgy, precision manufacturing, and thermodynamics, had given America sovereignty over the stratosphere. Japan's defenders could only watch from below as their cities burned, delivered by weapons flying in atmospheric realms they could reach only briefly at their limits, while the Americans cruised there comfortably, untouchable, systematically destroying an empire that had believed warrior spirit could defeat industrial might. The B-29 Superfortress proved that modern warfare belonged to nations that could manufacture miracles in quantity, that could build complex machines with automobile production efficiency, that could train civilians to operate advanced weapons through systematic education. Japan discovered too late that abundance was strength, that democratic industrial societies could outproduce hierarchical warrior cultures, and that altitude determined victory in an age when turbo-superchargers had made the stratosphere accessible to those with the technology to reach it and the industry to exploit it. If you've made it this far, you appreciate history told with depth and precision. This channel is dedicated to bringing World War II narratives that go beyond textbooks, human stories, researched from primary sources, told as they deserve to be told. Subscribe to support this work of historical research and storytelling that reveals how technology, industrial capacity, and human determination shaped the modern world.